Okay, in this video, we're going to talk about Spark Stream Static Joins. We're going to do a live demo and we're going to wrap up with a mistake which I see customers make commonly when taking the job to production. Okay, so let's get started. So Spark has two types of joins in streaming. One is called Stream Join and Stream Static Join. We are going to talk about Stream Static Join in this video. So when do you use Spark Stream Static Join? So when you have a fast moving source, in our case, I created like a IoT data source. And on the other side, you have a table which gets updates less often. Now, how do you define less often? So think it updates happening every 15 minutes, every hour, something of that sort. And the other side of the table, which is not streaming, should be slowly moving and shouldn't be like a big volume table. So imagine a fact joining a dimension. So in our scenario, what we have is we have IoT streaming data. Now this could be very fast moving. This could be 3 million rows a second, doesn't matter. And what we are trying to do is while this data is coming in, we are trying to join it with a device dimension table. So we can take the example further, which is here we have sensors coming online, emitting data about the device, stuff like that. And on the other side, we have a dimension table which has attributes about this device which has come online, right? And then what we're trying to do is join this, basically enrich the data and write out to a delta table. So that's what we have in our scenario. Yeah, our input source is synthetic, but it could be a Kafka stream, it could be a Kinesis stream, it could be just files landing on it. So it doesn't matter as long as we can create a streaming source out of it, which means Kafka Kinesis, Red Panda, or any kind of objects arriving on S3 ADLS. And on the other side, we have a delta table. And now we are going to join it and then write it into our IoT table. So this is how I set my experiment up. I'm creating low volume, 3 rows per second. You can do 1 rows a second, no problem. And then what I'm doing is I have a small dimension table and every minute I'm replacing or updating the table. Now, realistically in real life, I would say every 10-15 minutes is a reasonable number. What Spark is going to do for us is that it's going to process the input data in micro batches. And then before it process every micro batch, going to read the latest version of the data from the dimension table. Now I'm saying delta table specifically because this feature that every micro it will check if the data has changed is only for delta. So that is where this static word comes in, because if the dimension table was a Parquet table, JSON table, anything which is not delta, this wouldn't have worked. So if you had a job which ran for like 10 hours, the way this would have functioned is like Spark only at the point where it started the first micro batch, it would look up the data of the other table, and then every other micro, it wouldn't have cared if anything changed on the dimension table side. So that is where the word static comes into the picture. If you have a delta table, then life is easy. Even if the dimension table is getting updated throughout the day, no problem. After every micro batch, Spark will check if the data is there or not, and the join would happen. If your table has a lot of rows, you can apply some filters. You can limit the number of columns which you are going to emit. The reason is you can do a broadcast hash join if the table on the other side is small. Sometimes you can't make the table small, but you can sub-select columns. Right? So that's another way you can achieve it. And other features about this is that this is a stateless join. When you have a stateless join, the benefit which you get is that the checkpoint becomes very light because the checkpoint does not have any data in it. Let's get into the demo. So this is our table. This is our small dimension table. It's 5:41 p.m. right now. And like I said, in this table, basically what I'm doing is writing data at every minute. The application, by the way, has been running for 7 days. So it's all good. It's all tested. And as you can see, updates are arriving every minute in our dimension table. And then on the other side, this is our target. To this target, we are writing very fast. We are writing every 2-ish seconds. We are able to commit data to this table. Let me refresh my screen. You'll see the timestamps updated. The timestamp that you see is your local timestamp, by the way. Some people get confused by it. So you can see a lot of commits are happening into the table. Let me take you to the notebook. I am using DLB DataGen library to generate data. Again, I'm generating small volume, but I personally push this to million rows per second, no problem. you need to learn about how to create a synthetic data, I'll leave a hyperlink to one of my blogs. Basically, you can generate like a terabyte in less than 15 minutes or so. And it's very cheap also. You can do it in like less than $5 to generate a terabyte. But here's some code. I'll not go through every aspect of the code, but this is the data which I'm creating for the dimension table. And then what I'm doing is replacing the table every minute. So every minute you will see this one going off. And this is where I'm creating my synthetic data. So I'm creating my synthetic data about devices. This is what it looks like, the schema. And then I'm doing a stream static join. So here I'm joining my IoT stream data with my dimension table. So here I'm doing a spark.read.table, meaning I'm reading the whole table. And then I'm subselecting columns. And then what I did was I put a alias on the dimension tables updated at column. The reason it's useful is my stream has a event timestamp. And when I do the join, I wanted to contrast what version of the dimension table it picked up. So that's why I've done that. When you look at the data, it will start to make more sense. This is the write stream aspect. This is a command, which if you're on Databricks, you can run a display command. So after you have done your transformation, here I did my joining and I want to see what the data looks like. So I can run a display command. And this display command is amazing because it also works for streaming data frames. So here you can look at that it's showing the output. So I can validate if the output is making sense to me or not before I write it out. And if the output makes sense, then obviously I can basically do a delta table. So this is what I'm doing. Here I'm saying, hey, try to go very fast. Try to run a batch every second. And if you see here, the average has been about 1.6 seconds in the last 30 minutes or so. So that's the speed you are able to achieve. And this is running on a single node cluster, right? It's not like a heavy cluster or something. And then another small thing which some people are not aware of, which is on your cluster, you can actually run a code which is called spark.streams.active. And this will give you an object. And then you can navigate that object and figure out how many streams are running on the cluster. And then you can look at the output. Why is this meaningful? Is because you can use this information to control how many streams are running on your cluster. But just so you know, this feature or this information exists. So yeah, that's about it, which is we have a streaming table, streaming source. We have a delta table, which is acting as a dimension table. We are joining it and then we are writing data, right? Now let me quickly show you how the data looks like. So if you go to our dimension table, you will see this is the data which we have. Again, this data is getting replaced every minute. So you can have a million rows here in your dimension table. The only reason I've kept the data limited is such that people can see the output. Now, if you look at our joined data after we have done the join, as you will see, look at the relationship between the dimension updated at and event timestamp. So if you look at here, what it's saying that for the event timestamp, which came at 1635, the value which we got from our dimension table was 1600 seconds. Now let me refresh my screen because sometimes the output is not really up to date. Yeah. Now, if you look at it, the event timestamp is 1747 and the dimension value which got picked up is 1747,00 hours. I'll tell you why I showed you this. What we are trying to prove is able to figure out if the dimension table got changed. Remember, I showed you a value where there was a huge difference. Now I'll tell you a real life example. Common mistake which people do is when they create the stream, when they do this application in production, they do an inner join. It's not recommended. You shouldn't do an inner join when you take this job to production. Here is why. In my scenario, you saw that there was a timestamp difference, right? What could happen is that if another team is responsible for keeping up your dimension table, or if another job is responsible for updating your dimension table, this application can fail, or this streaming job fails, which is responsible for keeping dimension table up to date. This can lead to two kinds of errors. One is we did not get the right version of the table, or we could work with an outdated version of a table. Another thing, which is even worse, is that if a new device comes up, like you deploy a new device in the field, and that device's information has not made it to the dimension table, that row will get dropped, right? So if you do a left join where you have your IoT streaming data on your left, then what will happen is you can always run a query on the target table and identify things went wrong. And if things went wrong, you can obviously run a merge query and update the data, right? But if you have done a join, that row would have never made across in your final target. So that's the tip I'll leave you with. Whenever you take a job like this in production, try to do a left join on the IoT streaming data. And then what you can do is you can have a process which runs once a day, once a week, and verifies that the data quality of the table is correct. And if it's not correct, you can always run a merge or an update on the table, which will correct the data, right? Another thing which you should do is try to do a broadcast hash join. And the way you can try to do a broadcast hash join is by keeping the dimension table small. Now, what I mean by keeping the dimension table small is read less columns, right? Last thing I'll leave you with is that whenever you're running streaming jobs, if you click on structured streaming tab, you will see all your streams running. And if you give your streams good names, you will be able to identify which stream you're working with. So in my case, when I ran my code, I actually gave my streams a name. So you give your streams a name by specifying using this parameter called query name, and then this gets reflected here. Also, you will see display query 1, display query 2. So when I went to production, I actually put display queries, and you can see it's showing display query 2 here and similar thing here. Obviously, when you take code to production, please don't put display in your code. I did it just to show you, because what it's doing is consuming unnecessary compute because it's running the stream all the time. So just for you to know. And then what you need to do is check your input rate and process rate. And process rate should always be greater than the input rate if you have designed a good enough application. Yeah, like last thing which I'll cover is, so this is a streaming job which is running. You can look at the input rate, process rate, and you can look at the operation duration. So this is showing us data for the last few minutes, and you can see majority of the time the speed is less than 2 seconds for processing each batch of data. And the time when it usually goes up is when it's running optimize on your table and trying to keep your table compact and stuff like that. So that's about it. I'll put the link to the code alongside wherever the video gets posted. So you can always copy this code and take it. And yeah, you can push this a long way. I've personally tried it a million rows a second. This works perfectly fine. Try to do a left join. And then another thing is to keep the table which you're joining small by either putting or doing a select to limit to control the number of columns which are coming in. Because if you have smaller data frame, then it can be broadcasted. Okay, let me know if you have more questions. Thank you.